The beginning of the grid. Today we are finally going to spawn the grid in the game. It is not going to be a perfect grid, not all the grid types are going to be supported, it's gonna be a little bit buggy, but at least we are going to have a first version of the grid spawning in the game. And let's get to it. Okay, so in Unreal, the first thing I'm gonna do is delete everything we did in the previous video when we did the grid shapes. So I'm going to remove everything from the level and delete it. Then I'm going to save my persistent level. I'm also going to keep all my levels hidden except the lighting, because we're going to use this empty scene to spawn our default grid. Default grid that we still need to code, so let's do it right now. I'm going to go in Blueprints, in Core, in Grid, and I'm going to create a new blueprint class, which is going to be an actor. And I'm going to name it BP_grid. And open it. And in here, the first thing we're going to cover is the visual of our grid, which means that it's now time to decide which technique we are going to use to display our grid on the screen. And since our grid is going to be composed of a ton of static meshes, we are going to use the instance static mesh component, which is pretty much the same thing as the static mesh component, which you probably already know how it works, but it also adds the possibility to spawn a ton of the same static mesh in the level without being too expensive for the performances, which is perfect for what we need because we are really going to have a ton of tiles in our world. So let's see how it works. On the left, I'm going to add a new component, which is going to be the instanced static mesh, the second one right here. And then I'm gonna go on the right and select which mesh I want to display. So I'm going to select from the drop down and search for the SpawnGrid square flat. SpawnGrid square flat. And by default, it comes with the world grid material, which is the default material in Unreal, but I don't want that. I want to use the border material we created in the previous video. So I'm going to search for border flat square. MI_grid flat border square. Perfect. Let's compile to see the result. Okay, well, we don't have anything. We added the mesh to display, we also set the material of that mesh, but nothing appears in the viewport. And this is because the instance static mesh component works a little bit different than any other static mesh. Because we have to specify how many instances we want to have and tell the component where to display them. So let's add a first instance. I'm going to click on the plus sign right here. And already we have a first tile that appeared in the viewport. And if you look closely at the instance list on the right, if you expand the element 0, it's just a transform. Each instance of the instance static mesh component are simply transforms. And it is also the reason why this instance appeared right in the middle of the world. It's because its transform is located at 0, 0, 0 in location without rotation or scale. So if you set your material to the static mesh instance and it doesn't show up like it's all gray like the default grid in Unreal, it is because you have to change something in the material itself. So let's double click on the material instance right here. It's going to open the instance, and then you can double click on the parent to open the real material. Here, if you select the material node, you can scroll all the way to the bottom, and there is a checkbox that you have to check. It is called used with instance static meshes. You can make sure that this one is checked, and then your material should appear properly on your static mesh instance right there. So let's add another instance to see. Okay, nothing changed, and this is because it spawned right on top of the other. Let's expand the transform right there, and just for example, you can change the location to maybe 100 to move the tiles on the side. And here you go, you now have two instances of the same mesh on your viewport. Great, let's add another one. For that one, I'm going to expand the transform and move it to -100 in X. And then we can add a fourth one, which this time I'm going to move 100 in Y instead. And I'm gonna add a last one, which I'm gonna set to -100 in Y. Here we go, we now have 5 instances of the same static mesh that are displayed in the viewport, and they are all rendered at the same time by Unreal, instead of having 5 different static mesh components that Unreal will render one after the other. And we can now go see how it looks in the world. So let's compile and save this blueprint, go back in entry, and you can drag it into the world. I'm just going to place it in the middle, right there. And here it's the same thing, you see all your tiles, so that works perfectly. But in our case, we're not going to add all those tiles manually one by one. We are going to add them by code. And it's time to do it, so let's go back in the grid. And in here, I'm not going to delete those instances right now because I want to still have a visual in my level and in my viewport right here. But we are probably going to delete them later. But for now, let's go in the graph. In here, I'm actually going to ignore all those 3 events and I'm going to start by creating a new function. So on the left right there, I can go in the functions and create a new function, which I'm going to name SpawnGrid. So this function is going to be responsible to spawn our grid in our world. Perfect. But to do its job, the function is going to need a few inputs, which we are going to need to be able to spawn the grid at the right place in the world with the right dimensions and the right shapes. So what's the first thing we need? Well, I think it's the position, because let's say if you go back in the level, it is pretty important to know where to spawn the grid in the world. Do I want it there, here, here, or there? Or maybe right in the middle like it was before. So to me, that's the first important information we need to have to spawn the grid in the world. So let's go back in the grid, and on the right side we can add a new input by clicking on the plus on the right there. Since it's going to be a location, we are going to change the variable type from a boolean to a vector, and we are going to name it center location. So this is going to be the position in the world where the center of our grid should be. Okay, great. What's the next thing we need? Well, if I go back in the level, I think the next important thing is how big do we want to have the tiles of our grid? So let's say if I want to have them bigger than what they are right now, I'm going to scale my component like so. And in the opposite, if I want them to be smaller, I can then make them smaller. Something like that. And it is a pretty important input because we need the grid to fit perfectly with the environment we designed in the previous video. So for now, I'm just going to reset the transform of this one, and I'm going to go back in the graph and add a new input, which I'm gonna name tile size. So the size of our tiles. The next thing is how many tiles do we want to have in our grid? If we use this grid, for example, it has 3 tiles horizontally and 3 tiles vertically. It doesn't have anything for the corners, but ignore that for now, it doesn't matter. So let's say if we want to have a bigger grid, let's say 20 by 20, we will need to be able to specify how many tiles we need to have in both directions. So that's what we're gonna do. We go back in the grid and create a new input. This time it's gonna be a vector 2D instead of a vector, so vector 2D, which is only the X and Y component of a vector. Because we're not going to spawn tiles along the Z-axis, only the X and the Y. And for the name, I'm going to name it tile count. And the last input is pretty easy, it's the shape of our grid. Do we want squares, hexagon, or triangles? That's easy. Let's create a new input. For the variable type, we're going to use the enum we created in the previous video, so eGridShape, and pick the last one in green right there. And for the name, I'm going to name it shape. Perfect, we now have everything we need to spawn the grid in the world with all the right dimensions and shapes. Let's compile and save. And the first thing I'm going to do in this function is to save those variables here into real variables that are accessible in the whole blueprint, because we're probably gonna need them later on, and because they are also not gonna change while the grid is spawned, unless another grid is spawned, obviously. But in that case, the previous grid will be deleted and will be replaced by the new one. So those variables will be updated. So to do that, I'm going to right click on those variables and choose promote to variable. Make sure you're not clicking on promote to local variable because those variables are only available inside this function. And in this case, we want them to be available in the whole blueprint. So click on promote to variable. And then we have to name them. So grid center location. And then we do the same thing for the other one. So for tile size, I'm going to name it grid tile size. For tile count, I'm going to name it grid tile count. And for the shape, I'm going to name it grid shape. And then I can connect them together right here. And we now have all of our 4 variables on the left right there. And while we're here, we can turn on the eye on the right of all those variables to make them visible in the editor. And to see if it works, I'm going to compile and go back in the level and then select my actor in the level. And on the right here, I can see all those variables. Okay, perfect. Let's go back in the blueprint to continue. Okay, so the next thing we're gonna do is to change the visual of our grid here based on the shape of the grid that we received as input in this function. So to do that, I'm gonna get the instance static mesh on the left and drop it in the graph. Then I can drag from it and do a set static mesh. And here we have to specify which mesh we want to use, which in our case is going to vary depending on which input we received. And actually, we already did the mapping between the grid shape and the mesh to use in our data table that we created in the previous video. So let's access that. And to access it, you just have to right click and search for get data table row. Not the first one, because it's get data table row names, but the second one, get data table row. In here, you have to specify which data table to use, so I'm going to select in the dropdown DT grid shape data. And as output, this is going to return the structure that we created in the previous video. So I'm going to drag from it and simply search for break S grid shape data, which is going to allow us to access all the variables we set in the data table. So the mesh size, mesh, material, flat mesh, border, field, everything. And we can simply connect the flat mesh to the mesh of our static mesh component. And we can also set the material at the same time. So set material, connect it after the set mesh, and use the flat border material, like so. And we can connect it to the get data table row and connect it after the set grid shape, like so. And there's one last thing to do, which is setting the row name right there, which right now is square, but you can set it to hexagon or triangle. But we need to set it based on the grid shape. So what I'm gonna do is take the grid shape on the left, do a get in the graph, and drop it on the row name, like so. Unreal is gonna convert the grid shape from the enum value to the text value that is the name of our row. And that's it, this bit of code should already work. So let's go try that. But to test it, we have to use the construction script. So let's go in there. If you don't have it in your tabs at the top, you can open it in the left right there, so construction script. And this event is called whenever the object is modified or moved in the world. So every time we change one of these variables, this event will be called. And we are going to use it to call our SpawnGrid function. So we can connect them together like so. And for all the 4 variables right there, we can use the ones that we have on the left. So connect the grid location, grid tile size, grid type count, and grid shape. Here we go. So we should now be able to spawn our grid in the editor via the construction script. Let's compile, save, and go try that. Now in the level, I should be able to select my actor and change the grid shape to something else than a square to see it working. So I'm going to select hexagon. Okay, didn't work. Triangle? Didn't work either. Square? Well, it was already a square, so it doesn't really matter. Hexagon again? Okay, doesn't work. Why? Okay, the first question I have is my event called? Let's take a look at that. So I'm going to move it on the side right there so we can see it. And I'm actually going to take the grid tab and move it right here. If you want to easily see if an event is called, you can simply go at the top of your window and select which object you want to debug. And in this case, I want to debug BP grid, this one. And then once I change something on the actor, so let's say I change the variable to a triangle, we can see the flow firing right there. I'm gonna do it again just so you see. So right now I can see that my event is called and it should work. So why is it not working? Well, let's see further. I'm going to go in SpawnGrid. Okay, I'm gonna focus on this part right there, which is the part that interests me. And I'm going to do the same thing, toggle between. Okay, I can see that the flows seem to stop right there. If I do it again, you can see the orange line is stopping right here. So it means that it didn't find a row. It's weird though, because the enum should have the exact same name as the row name of my data table. So let's debug that. From the second pin, I'm going to drag and search for print string. And for the int string, I'm actually going to combine 2 strings together. So I'm going to drag from the int string and search for append. Like that. which let us combine multiple strings together. And in this case, I'm going to start by typing a message, so error dash row not found, something like that, space dash space. And then I'm going to connect the output of my row name here into the append string. And while we're here, I'm going to expand the print string and change the text color to red because this is an error, so we want it to be red. And I'm also going to change the duration from 2 to 5 because it's an error, we want it to be visible a little bit longer. Perfect, let's compile and save. Okay, the flow executes the print string. Okay, let's go see why. I'm going to reduce the window a little bit to see the text in my viewport and compile again. Row not found, grid shape, new enum 0. New enum 3, new enum 0. Okay, that's weird because this is not the name we wanted to have. And we are sure that the grid shape right there, the names are not new enum 0. Well, actually they are in the code. In the C++ code behind the enums, they are named new enumerator 0. And what we are seeing right here is the display name, not the real name of the value. But in our case, we want to use the display name. So how do we access it? Well, it's a little bit stupid, but it works. If you convert the enum to a string, like so, before converting it to a text, it gives you the display name instead of the real name of the variable. So I'm going to drag the enum on my print string, so Unreal creates me a convert to string, and then I can drag the string out of that conversion into the row name. So we are converting it back to the text afterwards. And I'm also going to connect it to my string like so. I'm going to clean up a little bit because it made a mess. And I'm going to make sure that my append is connected back to my string. So something like that. So now if I compile, okay, in my world, the shapes are not triangle. Okay, so that's good. But I still saw a few errors on the top. Row not found, none. Row not found, none. And there's a bunch of them. Okay, that's odd. And this is actually because this actor right there in the viewport of my blueprint exists. And it's also calling that function. So every time I compile this blueprint right here, the code is executed, but since the default value of my grid shape is set to none, it complains. It actually doesn't affect us because we sent it in the world, but in this case, since we don't want it to complain, I'm going to change it from none to square. Then I can compile and it doesn't complain anymore. Perfect, can save it. I'm just going to duck this window back in, and I'm going to focus on the actor in the level. And right now I should be able to switch between the hexagon, the square, and the triangle. Perfect, let's go back in the blueprint. Here I'm going to go back in my function, and we are actually going to need this bit of code right there a bunch of times. Because we are probably going to need to access the mesh size, the mesh itself, the material, the other materials, at a bunch of places in the project. So since we are going to reuse this bit of code multiple times, I'm going to collapse it into a function instead of duplicating everywhere. And it's also a bit ugly bit of code, like there's a branch in there and that's not pretty. So it's better to combine it into a function. So I'm going to select all those nodes, right click on one of them and click collapse to function. For the name, I'm going to name it get current shape data. And I'm actually going to convert it to a pure function. So we don't have to connect the white execution pin to it. Which I'm going to do by going on the top right corner and checking the pure checkbox. Like so. We now have a floating node. And just to make sure that everything was connected properly during the collapse, I'm going to double click on the function and go check the content. And yep, it makes sense. So we now have a nice function that returns us the row of our data table that we need. Whenever we need it. Perfect, that's all good. Okay, well, it's finally time to spawn our tiles by code. So let's do that. First, I'm going to go on the right, and we have to think on how we want to do it. So I'm just going to open a snipping tool. Okay, so now I can draw some stuff. I'm going to start by drawing the grid right here. Okay, so this is the grid we want to spawn, and we want to spawn all those tiles. So all the square that you see right there, we want to spawn them. And the way we want to spawn the grid is maybe by starting in the bottom left corner right there and go through all of our columns and then all of our rows like so. And then once we're done, we go to the next column and go to the next row and same thing, and same thing, and same thing until the grid is fully done. So we want to start at the bottom left corner right there. But right now, the only information we actually have about our grid position is the middle, right here. So we have the middle of our grid, and we need the bottom left corner. So we need to find out from the middle of our grid and the grid size and everything, where is the bottom left corner of the grid. So let's do that. I'm going to go back in the graph, and I'm actually going to create a new variable plus. I'm going to name it grid bottom left corner location, and change the variable type to a vector. I can now drop it in the graph and do a set and connect it after my set material. Perfect. And to determine the position of the bottom left corner, what we have to do is start from the middle and subtract the distance right there, which we can do by subtracting half of our grid horizontally and vertically, which is going to look like something like maybe x divided by 2 minus, and then y divided by 2 minus. Something like that. But let's do it in Blueprint instead. So I'm going to start with the grid center location, and I'm going to subtract the distance. So vector minus vector. And I can connect the output directly to the bottom left corner right there. And to find the distance, we have to use the grid tile count and the grid tile size, because we need to know how many tiles we want to go in both directions, and also the size of those tiles. Since we only want to subtract half of the grid, I'm going to divide the grid tile count by 2, so vector 2 divided by float, and I'm going to type 2. And then I will multiply this tile count right there, so half of my tiles, with the grid tile size. So I'm going to multiply vector 2 times vector 2, and I'm actually going to connect the grid tile size directly to the multiply. And with that conversion node, what Unreal does is removing the z component from the vector tree to convert it into a vector 2, which is fine in our case because we don't need the z-axis. And then we can simply connect the result of the multiplication into the subtraction, like so. And here Unreal is adding back the z to create the vector tree. Perfect, that should work. We have our bottom left corner. Okay, we're now ready to start looping and spawn all of our tiles. So I'm just going to go on the right there, and I'm going to use the grid tile count to loop through all my tiles horizontally and vertically. Since I want to be able to use them independently, I will split the struct. So I'm going to right click on the node and click on split struct pin. Then I'm going to create a for loop, so for loop, and connect it after the set grid bottom left. Here I'm going to start with the x, so I'm going to start by converting it into an integer by rounding it, so round. And then since here we have a count and in the loop we have an index, we need to do -1, so minus integer and connect it, because indexes are always 1 lower than the counts. Something like that. And since we're going to need to know which index we are in the current loop, I'm going to promote it to a local variable to access it later. So promote to local variable. Make sure to not click on promote to variable because we only want that variable to be alive during this function, not during the whole life of the blueprint. So promote to local variable, which I'm going to simply name it x, because this is the x index. Then for the y, I'm going to duplicate all those nodes, so copy paste, and move them after the set x here. And for the input, I'm going to use the y count instead of the x count. Something like that. And then I'm going to also promote it to a local variable. So promote to local variable, name it y, and connect it to the loop. And now if we combine the x and the y plus the grid bottom left corner that we set a little bit before, we have everything to find out where the tile should be in the world and set its transform. So let's do that. I'm going to start by creating a new local variable. So local variable right here, which is going to be tile transform. I'm going to change the variable type to transform, and I'm going to drag it in the graph and do a set. I can connect it after my set y, and I'm actually going to split the pin here to have access to the location, rotation, and scale independently. And let's go from the easiest to the hardest. And the first one is the rotation. Well, the tiles don't rotate, so that's good, it's already done. Perfect, rotation, check. The next one is the scale. So to find out the scale, we are going to use the grid tile size, which is the size that we want to use for our tiles. But we can't really just connect it like that. It will be too simple. And the reason why we can't do that is because the mesh we imported already have a size. And in this case right now it's 100, I think. So we have to take that into account when we set the scale of our mesh component. So let's get the mesh size, which is in the shape data. So I'm going to drag the get current shape data into the graph and break the output. Break. And here it is, the mesh size. So I'm going to divide the grid tile size, divide vector divided by vector, and connect them together like so. Which is going to return us the proper scale for our mesh. Perfect. Let's do the location now. This one's a bit more complex. So if we look at what we said before, we are going to start from the bottom left corner and go all the way to the top, like so. So let's do that. Grab the grid bottom left corner. And then we're going to add vector plus vector and connect it to the location. And what we are going to add is actually the tile index that we are processing. So let's say index 0, 1, 0, 2, 0, 3, and then 1, 1, 1, 2, 1, 3, 2, 1, 2, 2, 2, 3. So we're going to pick the X and Y indexes. But we also need to know how big is one tile, because it can be this big, or that big, or this big. So we have to multiply it with the grid tile size. So I'm going to add it right here. And then we can multiply them together. So drag from the grid tile size, search for multiply, vector times vector, and connect that to the plus. Then I can split the pin of my vector right there and connect the X in the X and the Y in the Y. Like so. And this should give us the right location for our tile. Perfect. So now we have everything to spawn the tile. Really, right now we have everything. Finally. So let's get the instance mesh and add a new instance. So add instance. And then connect it after the set. For the instance transform, we're going to use the tile transform. So drag the tile transform into the instance transform. And that's it. We should now have tiles. So let's compile, save, and go back in the world. Okay, they are not there. That's weird. Oh, okay, it's because there's no data in our variables by default. So the center location is 0, 0, which is fine, but the tile size is 0. So if tiles are spawned, they are tiny, tiny, tiny. And the tile count is 0, 0, so it's not spawning anything. So let's go add some default values that make sense. So I'm going to go back in the blueprint and change the default value. For the grid tile size, I'm going to set 200 by 200 by 100, I think. But you can set anything you want, it doesn't actually matter. And then for the grid tile count, I'm gonna start with a grid of 10 by 10. Okay, we saw the flow executing, that's a good news. Okay, let's go compile, save, and go back in the level. Okay, we now have tiles. Great, that's awesome. But the previous tiles are still there. Okay, that's not good. Okay, so these are the tiles we added manually. Well, we should still delete them when we spawn a new grid. So let's do that. Gonna go back in the grid, and right at the beginning of the spawn function, I'm going to give myself a little bit of space. So I'm gonna move this right there. And to delete all the previous instances, I'm going to drag the instance static mesh here and do a clear instances, which is going to delete them. I'm going to connect it. And I'm actually going to collapse this into a function because we are probably going to want to destroy the grid anytime we want in the game, not only when we are creating a new one. So I'm going to right click and do a collapse to function, which I'm going to name destroy grid. So now every time we are calling the SpawnGrid function, it starts by destroying the previous grid, and then it does all the spawning job. But we can also call the SpawnGrid function whenever we want. Great, let's compile, save, and go try that. Okay, that's good. I don't have my small tiles anymore. Great. And let's see if it actually works. So if I change the center location, okay, the grid moves, that's good. If I change the size, okay, the size changes, that's good. I can remove the tile count, I can add more, okay, that's great. Can I change the shape? Well, I can, I have hexagons, they are a bit weird, but they are there. And triangle? Okay, they are there too, that's good. They're weird though, but they are there, so that's good, that's good. We have everything we need. And if I put it to none, I have a bunch of errors and nothing spawned. Whatever, that's all good. Square. Okay. So we now have a basic grid, but as I said, it's a bit buggy. The triangles and the hexagons are a bit weird. And also if you, let's say, show a level, I'm going to show L square, I'm going to move the grid a little bit above so we can see it better. And we can actually see that the grid is not aligned with my texture. I can align it manually if I do something like that maybe. Yeah, that looks good. But I don't want to have to align it manually every time. So we need to fix that. We need to find a way in the code to always align it properly with the grid. Because otherwise, why did we create all those textures in the previous video if they can't be used as a guide? So yeah, let's use them as a guide for the grid too. But before that, we can also go take a look at how it looks in the other levels. So let's say I show my hexagon level, and then I switch the grid shape to an hexagon. Okay, they don't fit at all, like at all. If I align a few of them, okay, I have a few that are aligned, like this one is great, that one's nice. These one are completely off, these two, and what? There's gaps in the middle? Okay, yeah, we need to do something about that. But that one's nice. But yeah, we need to fix the hexagon grid. And it's actually the same thing for the triangle, which is here. If I show the level and switch to the triangle shape, if I try to align it with my level right now, can I? Okay, I can't really do it. I have the lines properly, but I don't have really the triangles. Like these ones are wrong, these ones are great, and they actually, like, some are missing. We don't have a triangle here. We don't have one there. So yeah, we have to fix the triangle and the hexagon. And I actually think that we did enough for today, so that's gonna be for the next video, which is good for me, because that means that you're gonna have to come back for the next one. So I guess I'm gonna see you there. Bye bye!